Hi guys, welcome back to the channel Tech Concepts with Ume. We're going to be starting our series on querying data from the PostgreSQL database. And the series is going to be, covered over a number of videos. So before I go any further, I want to request that you subscribe to the channel. If you look to the bottom right of the viewport of this screen of the video, you will see a red subscription watermark. If you use your mouse to hover around the red subscription watermark, a subscription button will appear. Please hit the subscription button. Also select the notification option so that you become notified when new videos are uploaded. So like I said, we're going to be beginning our series on querying data from the PostgreSQL database. Now, with respect to querying data, we use the structured query language. I have reiterated this so many times, but it's important that we continue to emphasize this. Now, the structured query language is an extremely powerful language that underpins extraction of specific data and subsequent insight generation from large data sets. It is used by several relational databases, which primarily store structured data sets. Now, these include PostgreSQL, which we're going to be using, Oracle, Microsoft SQL Server, and Microsoft Access, amongst others. Now, when using the structured query language for queries, our syntax will primarily consist of three parts. One is the select keyword. Now, with the select keyword, we're going to be listing attributes from one table or multiple tables where we hope to generate data from. The from keyword is used to list the table where our data or attributes are going to be elicited from. So it could be one table or could be multiple tables. And then our where clause specifies additional criteria using various operators and keywords that help to further filter data. For instance, you may have a database consisting of student information. Now, this student information will be represented in a table, perhaps called student. Now, this table may consist of the following attributes: student identification, first name, last name, age, address, and phone number. Now, you may then want to query data with intent to produce a result set of students that are below the age of 23. For such a query, each of the three parts of our SQL keywords will play integral parts. E.g., the select part will help us to identify the attributes, first name, last name, and age. The from part will help us to identify what table this is coming from. In this instance, the students table. And the where clause will specify the additional criteria, indicating that the age of the students returned in the result set must be less than 23. Now, with respect to our practice exercise, we're going to be implementing this entity relationship model. If you look back at our last video where we talked about, other ways of generating data for your PostgreSQL database, you will note that we did indicate that this schema or entity relationship model should be implemented before we start our query exercise or exercises. Now, for you to be able to implement this schema, you can look at prior videos. However, if you do get stuck, look at the previous video before this, and you will see in the description section a link to a Google Drive where a Word document has been placed containing the codes to implement this entity relationship model. Before we start our practice exercise, I wanted to point out a very important concept we need to be aware of with respect to our where clause. Now, with our where clause, primarily we use operators, and these operators help us to specify additional criteria that we may need to get particular data sets that we want. Our operators include the following: less than, greater than, less than or equal to, greater than or equal to, and equal to. Now, we're going to be starting our practice exercise. So now I am going to navigate to, my command prompt. Okay, so I had my command prompt opened up already. If you haven't opened yours up, open it up and then log into the PostgreSQL environment using the, PSQL login command. Now, once logged in, the first thing we're going to do is see what tables we have in our database, Postgres. So I am going to use the command \DT, and I can end it with the semicolon. All right. And here we're going to see that we have the following tables. Now, the tables which are important for our practice exercise with respect to queries include the following: our branch table, our customer care assistance table, our customer table, and our order underscore tab table or order table. All right. Now, it is hoped that by now you have implemented the specified, schema from the last video. As such, the list of relations displayed should include these four tables depicted, in the schema, just like I have pointed to. For our query practice, we will begin with the customer table. So let us enter the command that produces a result set of all records in our customer table. So I am going to say select all, which is the star symbol, from customer. And I'll end it with our semicolon. And you'll see that we have a list of entries in our customer table. Now I'm going to scroll to the end of this so that we can begin our specific, query examples. Okay, so we should have a result set that displays all of the customer records in the database, as I have just demonstrated. Now, based on our illustration in the slide, of the constituents of our, SQL query language, we will perform one example of a query action using our customer table. In this example, we will attempt to produce a result set of customer names and ages for customers below the age of 23. Now, this command, in accordance with our set criteria, will produce a result set with only the attributes name and age from the customer table for customers that are younger than the age of 23. So let's begin. So here we're going to say select. Okay, selecting action will include two attributes. So we're going to select one name and the other one age. So here we're going to say select name, comma, age. All right. I should point out that your entire query can be written in one line. However, you may decide to split it up. We're going to split it up so that you can follow along, just like we demonstrated when we started with our slides today. So select name, age, press the return key, and then we say from. Table here is customer. So these are the attributes we're selecting: name and age. From specifies the table name. All right, so customer in this case. And then the where clause is going to specify the additional criteria. And here we're saying where age is less than 23. All right. And once I, use the semicolon and I press the enter button, then we're going to see names and ages of, records in our customer table that are below the age of 23. Now, let us address a more practical example using the same customer table. Let's hypothetically imagine that the clothing retail store would like to determine customers who are worthy of purchasing clothes on credit. But for them to be able to do this, all right, they must earn above 100,000 in monthly income. We may decide to perform a query to determine customers that meet this criteria. Now, to generate such a result set, we will use the command as follows. We will say select, okay, and we're going to say name, age, or sorry, let's use just the name and monthly income for now. Name, monthly income. Again, from table customer, and where monthly income is greater than 100,000. And I am going to end with my semicolon, and I'm going to press the enter button. And here you will see that every record from our result set contains, only the two attributes we had requested, which are the names and the monthly incomes. And you will also see that all the monthly incomes listed here are above 100,000. All right. They're all above 100,000. So here we have 500,000, 130,000, 167,000, 266,000, and it goes that way. They are not arranged in hierarchy in terms of ascending or descending order. We're going to get to that later, but that's that. Now, we can decide that the emails should be sent to, these 20 customers, informing them that they are qualified to access clothes purchase on credit. Note, our where clause is not limited to the specification of one criteria, as we have demonstrated in these two examples. All right, we can specify multiple criteria with our where clause. Again, we will use the same customer table, okay, to demonstrate this. Now, let us assume that for this same demographic, people who earn above 100,000, okay, that's, we want to be able to determine those below the age of 25 in this category in order to market a trending accessory that it is believed young people will be fascinated by. So in this instance, our where clause will consist of multiple criteria. And the age criteria we want to include to this demography of people who earn above 100,000 will be people less than the age of 25. So you will note here that we have two criteria specified for our where clause. The first is that they must earn more than 100,000, and the second is that they must be less than 25 years of age. So to carry out this query, we're going to use our command as follows. Select name, age, monthly income. Again, from our customer table, where age is less than 25 and monthly income is greater than 100,000. Sorry about that. Note here, considering that we are specifying more than one criteria, one, age less than 25, we have to use our and keyword and monthly income, all right, greater than 100,000. And I am going to finish with the semicolon and I'm going to press the enter button. And you see here that we have 8 rows returned in our result set. And everyone here is less than the age of 25, but also they all earn more than 100,000. Now, note when applying, criteria to characters, like we're going to do with our next example, right? The values of the said characters will be placed within single quotes. We have to mention this because if we go back to our examples, all right, you will note that the values here do not have any quotations or they're not embedded in quotes. 25, which is an integer, is not embedded in any quotes. Also, 100,000, which is an integer as well, is not embedded in any quotes. Now, if our criteria was going to include a value that was character varying or character, then we will have to put the value in quotation or single quotation marks, like we're going to see with this next example. So for this next example, we want to produce a record for Devin Cook. Okay, so we want to see all the attributes for Devin Cook. So for us to achieve this, we're going to use the same select command. So I'm going to say select all because we want all attributes to be included for this person. Okay, we can use multiple rows as well. So I am going to press the enter button again. And here I'm going to say from customer. And I am going to say where name is equal to, all right? So in single quotes, then we're going to say Devin Cook. Now the value is going to be case sensitive, so keep that in mind. However, the value is stored in, the database, it should match that same, case right out. Okay, so here I'm going to end with our semicolon, and I'm going to press the enter button, and you'll see it brings up the record for only Devin Cook. Okay, now the point with the above example is that when the value for criteria to be specified is a character, the value must be in single quotes. As you can see here, we have single quotes, okay, to guide our value entry. If you do not include the single quotes, you will receive an error message as the output. All right. So we're going to stop this video here, all right? We do not want to stretch the length of the videos. So in our next video, we will be looking at other important keywords that are used with our, where clause. We'll also be looking at other, clauses, all right, that are important for arrangement of our entered records, as well as aggregate functions. All right. Thank you for tuning in. I will request again that you subscribe to the, channel. And I will see you in the next video. Thank you.